Hopefully your first step was isolate. Keep going, sorry. Shh. I'll go quietly. You guys good?
Yes.
What's all this showing? There are many different ways of writing the answer. Now, probably what would be the multiple choice make it match answer? Probably this one if it was a multiple choice question. This would probably be the back of the book, but could it come in other forms? Okay. Introducing you guys to the slight reduction. It's a part of the struggle of calculus. The making it match is sometimes the hardest in calculus. All right, over here. I'm going to give you guys a couple more seconds, meaning I'm going to slowly tackle it. So you guys will have a little bit more time to work on it. I'm just curious what your first step was. Condense? I love it. Keep going if you need to. You can keep talking too. Condense? I love it. Some groups need to reconvene because maybe you didn't start here. I'm going to give you a 30-second handicap, 30-second head start, in case you need to reevaluate. Go, buddy. Give me a thumbs up if you individually got the first one right. Keep that, well, or put your and/or, put your thumbs up if you got the second one right. Okay. Majority of you got at least one right. Majority of you got at least one right. I saw a couple people that seem to have gotten left behind by their groups. Should fail the whole group then. Struggle. Okay. Don't leave anyone behind. But go ahead. Questions. On which one, Kim? The first or second? Okay. Kim asked something about the domain. What is she referring to? I know what you mean. What does she mean by the domain? What is she considering? What is she being careful of? Extraneous. She's being careful. She's being cautious. Because what was in the original problem? And what's not allowed to go inside the logarithms? So here's the struggle. Don't I have a domain problem here where x has to be greater than 0? And what's true here? The domain of this first little piece is x has to be greater than 0. What's the domain of the second little piece? Because there's two logarithms. X has to be greater than 1. Now, both of these need to be true. So ultimately, even 1/2 still wouldn't work, right? It would pass that one, but it would fail that one, so it failed the whole function. So technically, what domain am I actually having to be careful of? That one. If I did the intersection of the two, or what's in common between the two. But hold on. Kim, thanks for bringing it up. Am I okay? Whew! All right. If it was anything 1 or below, would I be in trouble? And I would have had to say extraneous. But because 2 is greater than 1, or you could say, plug in 2, it's positive, we're good. Plug in 2, it's positive, we're good. So it's okay. Now, why did we not think of it over here? Uh-oh. Well, it has a little bit, right? What's the domain? Because it's an ln, and an ln is a logarithm. X has to be greater than 0. But is e to the, well, I don't know what e to the is. Pause. What's e as a number? 71828, 2.8-ish, 2 point something-ish. 2 point something-ish to the 3 1/3 power. 2 to the something raised to the 10th power cube rooted. 2 to the something-ish cubed times the cube root of. Am I okay? Is it going to be greater than 0? Because it's 2-ish, almost 3-ish, raised to the 3-ish, which would be like 27-ish, and then raised to another cubed root-ish, which is, I don't know, something more than 27-ish. Anyway, it's a positive number plugged into an ln. I'm good. I'm golden. Thanks, guys, for bringing that up, the whole extraneous problem. Only every now and then do you find an answer that is extraneous, and usually it's when you have like multiple answers and 1 or 2 of them don't work, but the rest do, usually. But remember, we only have to worry about them when we have logarithms to begin with. Any final questions on the first or the second? Go, team. Let's go grade our homework. Come on, color pens. Let's see what questions you guys got stuck on, because you guys did great on the bell work, so let's see what went wrong. Maybe something to do with that? No? We're good on that one? Okay. Let's go see. Number 2, extraneous. Hey, I primed you guys for that one. Number 12, 0.01. What? Why are they doing decimals? Because the answers could be written different ways. So they just wanted you going to decimals so that whatever form your answer was, you'll know whether or not you're right. 1 over 100 would be the best answer for that one, but fine, 0.01. 16, you set them equal to each other. Intersections, they must be equal, which happens when, x was 9. Did you guys realize they were asking for the entire point, though? So 9, 2. Careful, if that was a long answer and I asked you for a point and you only gave me an x, you'd be losing some points. That's funny. Yeah?
On the first one to approximate and then figure out if you were right.
Oh, so you could have another answer. They didn't put down your approximate because they didn't know what it was. But were you close to 9.2? Oh, that's good. That's a little closer. 2.7 would have been a little. Okay, 9.2. Not my height. Number 24. Final answer. The decimal was just to see if you got it in the right form. Because some of you, actually possibly many of you, I would have done exactly what the book did. Not because I'm a genius or smart. It's just because the higher you go in math, the more you come to like ln's. And I know that sounds weird, but the more you like ln's. Can anybody tell me another way they went that should have ended in the right decimal, even if that looked totally different? Yeah, Tony.
I got negative log 4.
Why would Tony use a log base 4? Yeah. Was that wrong? No, it's not wrong. Is it different? Yeah. The higher you go in math, the more you like ln's. And you're like, no, I'd rather use an ln all day long. Okay, there's a reason for that. But it's okay to use a log base 4. And what you do, you would negative 3t is equal to log base 4 of 0.10. You would divide it by a negative 3. This would have been your answer, which looks way different than, well, wait a minute. Actually, they look kind of similar if you know what formula. Change of base formula. Because change of base formula would have said, okay, that little divided by 3 thing, I have to deal with him separately. But this logarithm, I can make it any log I want. So you could have actually made it match with the change of base formula. Why are they having you in homework find the decimal? If you plug this in, it would have been 0.554. So you would have known that you were correct. It just was a different representation of the answer. Does that make sense? Okay. Now if you didn't get 0.554, either you plugged this in wrong or you made a mistake. Careful. Kim. Well, what was that example? I think I did it quick while a lot of you guys were leaving. This example that most of you didn't see me do on Friday, this is a good reason. Most of you didn't see me do this example, but I put it in the notes just in case you went checking it out because you got stuck in homework. Why do you think I used an ln in this one instead of a log base 3, log base 2, log base 4? Oh, what was true about their bases? They were different. So I couldn't have used a log base 2 or a log base 3. It wouldn't have worked. It wouldn't have fully worked. It would have gotten rid of one, but it wouldn't have gotten rid of the other. So what I did is just say, you know what? I don't like log base 2 or log base 3 anyway. It's not in a lot of formulas. Those aren't used in a lot of future formulas in math anyway. So I would have been like, forget it. The whole log base doesn't work. So I'm just going to use ln. And because it's a logarithm, what happens to the powers? They go down. And once they go down, I can go ahead and distribute. I end up with some terms having x's, some terms not. If I move all the x ones on one side, I can factor out the x. Oh, I got them. And I can divide. Well, actually, I use the quotient property, then I divided. Anyway. So Kim, this is a good example because log base 2 and log base 3 won't be good enough, if that makes sense. So I'd rather use ln if I have to use a logarithm anyway. Sorry, that got us back into notes. I meant to come back into homework. And then otherwise, Kim, I can't fully explain it besides the fact in calculus there are derivative rules. It's a huge fundamental piece of the whole year of calculus, and the rule for ln is much, much, much easier than the rule for any other logarithm. So that's why ultimately the more familiar ln, if you were to be given another log, it might be easier to make it ln for future stuff you have to do. Number 30, divide, ln both sides, divide by -4. Dun, 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 dun. Hopefully the decimal matched. Remember your form might be different, the form of your answer. Maybe you did all over -4, but hopefully your decimal matched. Number 36, oh, this one's like the one I just showed you because there was a 2 and there was an e. Could you have chosen log base 2? Yeah, but it would have gotten messy right there. Could you have chosen ln? Yeah, it would have been nice here, but it's messy there. Oh, well. Remember, anytime you have a logarithm, what can you do to the power of the argument? Bring it down. If the logarithm doesn't cancel, you can bring the argument down, or I should say the power down. So this one was nice, ln and v canceled, 1 minus x, but this one, ah! Now pause. If you follow the steps I just did, maybe some of you want to go back and watch me do that example at the very end when you guys were all walking out on Friday. But ultimately, there's an x in 2 spots. There's absolutely no way to get these two together unless you undo the multiplication. Get addition and subtraction only. Move the x terms, anything with an x, on one side so you can factor. And then all of a sudden, the heavens open. Oh, light comes down. It's like solve by dividing. Dun, 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 dun. But you have to, in order, in any weird situation like that, undo the multiplication, just get addition, subtraction, then rearrange the puzzle pieces to where all your x's are on one side, factor, and then you're done. Okay. I think Pocahontas inspired me. Number 50. Did you guys do e to both sides? Square both sides? Wait, did anybody have another way of tackling this problem? This way works. Did anybody have something that made it easier from the very beginning? Anyone? Kind of expand. How could you rewrite the square rooty dude? To the... Oh! What could you do to that guy? Ooh! So really he's just at 1/2 times? Ah! So you can multiply by 2 and multiply by 2? Yeah, you still have to do the e. But don't you have the 10, which might have been a little easier than squaring? Some of you got stuck with the power to a power you multiply. Shouldn't have. But maybe some of you are like, hey, 1/2 times 2, that's easier. And then just do e, e. And then you can go ahead and add 8 and have 8 plus e to the 10th, or e to the 10th plus 8. Well, it's a big number, 22,000. 34.466. Anyway, I just wanted to show you an alternate way of going. But that way works fine. That way works fine. Number 60. Please tell me you condensed first. Then maybe one-to-one property. Then a little bit of algebra with factoring. Wait a minute. After factoring, you got 2 answers. Only one works. I don't get it. Just kidding. Wasn't the domain x greater than 0, x greater than -2, x greater than -6? And if you put all those together, the lowest x can be is 0. Because if it goes negative, this one's going to fail. Well, then the -3 is extraneous. If you plug them in, that's illegal. The -3 was extraneous. No. I know. The problem in pre-cal, there's so many different specific mistakes or problems that can happen in each chapter. Like, I'd have the room filled and then it wouldn't have the same impact. Like, just don't make this mistake. You can always make animals for yourselves, though, each chapter. Last but not least, were we trying to find the intercept? Is that what was going on? The zeros, the intercept? What were the directions? Oh, just solve? Oh, sorry, I saw the equals 0. So it could have been like a, hey, set y equal to 0 and solve. Never mind, never mind. Solve. What happened between step 1 and 2? It wasn't magic. Multiply x squared on both sides. Undo the division. Multiply x squared, poof, there it goes. And then 1 minus ln of x equals 0. Move the 1, e to both sides. E to the 1 is just 1. Dun, 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 dun. That's bound to be the end, right?
No.
Ah, there's another one. Okay. I know it was a little bit crazy, but ultimately they gave you an equation and they said, hey, set the p equal to 169. Yeah, they put words in there. But once you set the p equal to 169, all you had to do was isolate, divide, whoosh, got it, subtract, whoosh, got it. I know it's weird, but subtract, whoosh, got it. Multiply, divide, 4 divided by -0.09662 ends up being this number. He's now on top. Now subtract the 4, now ln both sides, now divide by, done. I know this seems crazy to you, but guys, this is the kind of stuff that happens in higher math. This is what we call a logistic model. You could see him in statistics, you could see him in probability, you could see him in Calc BC. The reason that we're going over logarithms and especially ln's and e's are because in higher sciences and maths there are equations with them in it, and you need to know how to solve for labs, for lectures, for test problems, etc. in many future classes. Here's a super silly example. Previous student took a test last week, 2 weeks ago, over at CSUN for her, what class was it? Microbio? I think it was microbio. I might be wrong. And guess what random little concept came back from the grave to haunt her just a little bit on a test problem? She was supposed to find slope for the specific application in this lab. Was it a lab test or was it a chapter test, unit test? Anyway, she was supposed to find slope, but they had never once talked about or reviewed if you needed to find slope between 2 points, because what they had been doing the entire chapter and all the labs, etc., had gone through 0, 0, so it was just the y over the x. It was technically -0 over -0, but they had never reviewed the slope formula. Teacher just assumed you should know how to find slope, gave a harder problem on the test. She accidentally did y over x instead of y2 minus y1 over x2 minus x1, because they hadn't reviewed it. It was something she was supposed to know from forever ago. That's something as easy as addition or subtraction to the professor. So if you get this equation someday in a lab or on a test, will you know how to get x by itself? I don't know. I hope so. But what do you need? A lot of very careful work and eventually an ln. Yeah? So, long story short, when p equals 169, the demand is 983 phones. Oh, it's a cell phone one. I forgot about that problem. Okay. Is there a B? Where'd he go? That's all right. Who is this? Number 80? What? Oh, you're supposed to plug in 299? Oh, sad day. Someone who got letter A right, what did you get for letter B? And let's compare to other people's answers. It should be all right. 84? Perfect, 684. We had a few people match up on that one, so I'm pretty sure it's the right answer. All right, questions that we have, evens or odds, preferably odds. Those are the ones you tried, couldn't get, knew the answers, could check Calc Chat. Gavin, 55, anything before 55? Should become an auctioneer, going once, going twice. Come on, Paige, ain't nobody got time for this. Okay, number 55. 36? Oh, 70, okay. Let's do 55 first, and then we'll go to your Tony. So number 55, the directions are just solved for x, right? From what you guys have seen in class today and the evens that we've worked on, what do you think, or even the bell work, the opener, what do you think we should do? Yeah, condense. Because if you condense, all of a sudden the ln is in one, remember? Isolating the ln, getting it in one spot. Condensing can do that also. Now what should we do to both sides? As soon as we condense the ln, we can undo it with an e to the power of. Now, hold on, we've done enough of these just today alone. What do you think we should do with this guy? Multiply him on both sides. We can't deal with the division. We got to get him out of there. But as soon as we multiply, I know, it starts looking scary, but hold on. Remember, I said we need to get just addition and subtraction to get the x terms on one side. So what am I going to do to the e squared? Distribute. I'm going to end up with e squared x plus e squared. Get all the x terms on one side. So subtract that e squared x. And what was the purpose of that? Now what can I do? Factor out the x. And when I factor out the x, Gavin, a simple division will take me home. So I condense to get the ln in one place. With an e, everything's nice. Subtract. Got it. So e squared over 1 minus e squared is the final answer. Tony, you said number 70, what, bud? 73. Do you guys see the little calculus symbol over here? Warning you that some of this math comes back later. Learn how to deal with it now. Interesting. Okay, you have to solve. How do we solve? Factor. I see common factors. Don't you guys see GCFs? It's equal to 0. Usually we're used to factoring when stuff's equal to 0. I see a 2x that can come out and an e to the 2x. And what's left is an x plus 1? Divide by 2, gone. Divide by x, and x is left. Divide by, he's gone. Divide by 2, and x and e to the, everything's gone. Now what do I do when I have factors equal to 0? Set each 1 equal to 0. Divide by 2. Got it. If you guys tried to do 2 equals 0, P.S., it doesn't work, so it just doesn't give you an answer. X equals 0 would give me an answer. X equals -1 would give me an answer.
But
do you know your math skills and your e's and ln's well enough to solve? What do you do to both sides? That's just 2x. What's any logarithm of 1? 1 is always what power of any base? 0. Oh, we already had that one. That's silly. X equals 0 and 1. No logarithms, no extraneous domain problems, so we are dun 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 dun. Any more evens or odds? Oh, not the entire thing. But I can at least, what I can do is show you the step-by-steps myself. So let me go to, it makes sense plugging in 169, right? To the formula. Okay. Then after that is probably where it got hard. If you understand how to solve A, same procedure for B, just with different number. I think it's 199, 299, something. Okay, I see x right here, but I need to move things away. I can't even get in here until I divide. So I'm going to divide by 5,000. I'm not going to go to decimals like the book did because I don't have a calculator and I don't want to waste time.
5,000? Mm-hmm. Okay, now I know where to go.
Oh, but the steps make sense after that? Good. Good. Never mind, we're good. Unless someone else wants that one worked out. It was a hard step-by-step problem. Okay, so let me go. Okay, I'm going to subtract the 1, which could be like plus a negative 1. Then I end up with negative 1. Remember, I don't have a calculator, which is okay, because you didn't have to be doing decimals this whole time. I should be honest, I think it's kind of nasty to do decimals the entire time. Seen enough times this year, hopefully, division to know we have to get rid of that division. What we do on one side, we must do, be careful, on the other. Here's where it starts to get messy. Because I need to start whittling this guy down. Now, just for sake of simplicity, I'm going to go ahead and leave this guy where he is. But since this is a constant, this is something I can plug into my calculator. This is a multiplication, I just didn't have room. I'm going to go ahead and divide him. That way, this guy alone. Then I'm going to go ahead and subtract 4 from both sides. Because subtracting will get rid of that guy. Then I see I need to undo finally, E is alone, so I can do ln of both sides. I have my negative 0.002x is equal to ln of 5, 2, 3 minus 4. Last but not least, x is equal to negative 1 over, I could just divide that guy to the other side, times ln of negative 4 all over negative 1 plus 169 all over 5. If you plug that into your calculator, dun, 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 dun. Could you have done decimals all along the way? Like, what's that as a decimal? 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 Yeah, could have. I'm just lazy and would rather just plug it in once, but you have to be careful. Kiddos, with that, we need to go ahead and introduce section 3.5. No one asked about that one. Maybe we'll see that one as like an opener tomorrow. Make sure that you guys know what you're doing. Oh my. Things got funny. Things got weird. That's okay, though. I'm going to erase all this anyway so you guys can write it down. I don't know why all this stuff got weird, but that's okay. Step number 1. Oh no! Do you guys see models? Do you remember what happened in models when we saw them in chapter 1? Oh, it didn't scar you guys that badly? Word problems, section 1.10. Word problems. But wait a minute, wasn't 85 a word problem that we just did? It had words. We had to plug in a P for price, so we had to solve for an X number of phones. Maybe it's not that different. Guys, the reason that we have the final section of chapter 3, the final section of chapter 3 is to basically cement what I've been saying all along. You were supposed to, all of chapter 3, be mastering the ability of dealing with e's and ln's, exponentials and logarithmics, so that you could solve models, equations using them, which is very, once again, very applicable in the sciences and the maths and the STEM fields, because so much natural growth and decay is modeled by exponential logarithmic functions. This will be helpful in any future science classes, science labs, to have this really good foundational understanding and hopefully mastering. You guys got introduced to this last year. But we were trying to up your game. We were trying to improve your skills. So this is the section of all puzzles. Remember I told you at the beginning? It's all about solving the puzzle. It's all about solving the puzzle. Here's the dealio, guys. This homework is technically not due as you guys are writing. It's technically not due until Wednesday. Not because you couldn't try it all tonight, but because you'll probably get stuck a place or two. So tomorrow, I'm going to see what questions we have. I'm going to see what problems we got stuck on, to try to give you some clues, some hints, maybe even have some class time to work on it. But we're also going to probably start our review, because depending on you, you could use tonight to fully attempt section 3.5. It's just the section of puzzles. It's the section of puzzles. You read a word problem. What's the first thing you should do? Figure out what equation that you're using. Maybe they give it to you. Maybe they give you clues, hints, wordings where you make your own equation, like section 110. Figure out who are your variables. Who are the key players? Check out what's in there. Is there a logarithm? Is there an exponential? Okay, you know you have to isolate. You know you have to use its inverse operation almost always in real equations. The one-to-one property rarely shows up. Almost always you have to do an inverse or just throw in some ln's to undo multiple exponentials. Use legal math. Carefully watch out for what they're asking for. If they're asking for a time, make sure you're getting a T alone. If they're asking for a price, make sure you're getting a P alone. If they're asking for a price, make sure that you label it with dollars. If they're asking you for a time, make sure you label it with seconds or hours or minutes or whatever the label is in the problem. Are there any ones where you need dimensional analysis, building bridges to get rid of what you don't want to make sure your units match up? Probably not in this section, but it's always a consideration to keep in mind. Let's check out the notes on this section. Now, what did I just skip? I'm going back over them. There are some special equations that show up. There's a special exponential growth equation. There's a special exponential decay equation. There's special finance. Where are my finance equations? Some of you might want to take a picture of this page. This is the most important page, to be honest, for all of homework, in the sense of the models that you're going to see most often in maths. It's a basic exponential equation. Y equals a coefficient e to a coefficient x. Growth, it's a positive, so it's going up. Decay, there's been a horizontal flip, negative going down. But I had you guys take a picture because interest is also a place where e shows up, or exponentials, variables in an exponent shows up. And these are formulas you guys have seen before. I know you have because I helped some Algebra 2 kids with homework. I think this came earlier for them than for you. But you might want to go to the book and look at an example to be like, who's R, rate, decimal, not percent. Who's N, how many times a year, annually, once a year. Quarterly, 4 times a year. Monthly, 12 times a year. Daily, 365 times a year. Have your calculator in this section for sure, for sure. But there are equations. They might not always give it to you. You might have to go find it. And so I'm just letting you know that there are some models, there are some equations. I'm not going to make you necessarily memorize any of them for the test besides interest ones, in the sense of having to write b greater than 0, b less than whatever with the equation and the swoops, there they are. But each equation has a general pattern to it as well. And once you get out of the general exponentially ones, you get into some other weird ones that still have an E, Gaussian. Oh man, that's huge in statistics, the normal bell curve. Anyway, there's an E in that, but the graph looks way different because it's way more complicated. Logistic growth has to do with like a disease spreading, but the population is limited, so it can only go so far, etc. Or like, oh no, the population of elk is overrunning, like it's going crazy in like Colorado or something. Oh, but then there are predators that are going to kill it off, hopefully, unless there are no predators, and then we have a huge issue. Anyway, yeah, humans, if you start letting them go ahead and start shooting. But guys, the main idea is there are puzzles. Go play with solving them. And we'll have a little bit of time to go over questions tomorrow before we start our review. Test is on Thursday. Bye, guys. I'll see you later. If you have any questions, I'll be here a little bit today. Lunchtimes are probably better to get me. Lunchtimes are period 7s, but I'll be here a little bit after school every day. I would have it as attempted as possible. It's not technically due until Wednesday. So no Google Classroom tomorrow morning.